NASA's live feed went silent in exactly 3.7 seconds, the moment twin, perfectly symmetrical blue jets erupted from an interstellar object not meant to be understood. What followed wasn't a glitch, it was a digital eraser. Deleted links, a classified tag. The object wasn't just glowing, it was accelerating, breaking into 16 pieces, and each fragment was still active. This wasn't a comet, it was executing a sequence, and what came next left scientists speechless. An object from the very beginning. On August 6, 2025, the Automated Telescope Survey in Chile flagged something moving against the backdrop of stars. At first, it was just another entry in a long list, but when astronomers calculated its path, a wave of excitement spread through the community. We've got a big update, a huge update on our favorite interstellar object. It could be the biggest update in the solar system. This was no ordinary comet from the outer solar system. Its speed and its trajectory were off the charts. It was moving too fast at too strange an angle to be bound by our sun's gravity. It was a visitor. Specifically, it was only the third confirmed interstellar visitor ever seen. This was a big deal, and we have a better idea of the orbit of this object. This might be a brand new, unknown, potentially hazardous asteroid. The first ʻOumuamua, discovered in 2017, was a total enigma, a rocky, cigar-shaped thing that showed bizarre acceleration. The second, 2I Boris, in 2019, was comfortingly normal. A classic icy traveler. This object has been traveling through interstellar space for hundreds of millions of years, billions of years. So the world was watching for number 3, hoping it would answer the questions ʻOumuamua raised. Would it be normal or strange? 3IATLAS answered that question. Almost immediately. It chose strange. The first anomaly was its road into the neighborhood. It wasn't taking a gentle looping path. It was on a radical high-speed dive straight toward the inner solar system. It aimed directly for the sun, like a bullet on a final fiery course. This extreme trajectory made scientists sit up and take notice. It was an aggressive, almost purposeful path, is that it's moving along a trajectory that is very special. Then came the first scientific observations. As the sun warmed it, the object began to release gases, forming a hazy cloud called a coma. Scientists analyzed the light from that coma, looking for chemical fingerprints. What they found was confusing. This comet's really cool because it does have that tail from the sun's radiation blasting it, but it also has a forward-facing tail. The basic ingredients were there, like carbon monoxide and dioxide, but the recipe was all wrong. The ratios of certain elements, particularly metals like iron and nickel, were strange. They didn't match the expected blend for a simple ball of interstellar ice. It was like finding a cake that used cement powder instead of flour. The components were familiar, but the result made no sense. At the same time, amateur astronomers around the world started reporting something with their own telescopes. The comet had a color, a persistent, vivid blue tint. Most comets glow white or faint green. This electric blue was unusual. The official explanation was quick. It must be ionized carbon monoxide, a rare but possible effect. People accepted this, but the visual oddity stuck in everyone's mind. The sun is here, and the comet's here. The sun sends the solar wind to the comet. That sail goes behind the comet. It was the first thing anyone would mention. Hey, have you seen that blue comet? So the early picture was of a highly unusual but not impossible object, a weird interstellar comet with strange chemistry and a funny color. The scientific establishment settled on terms like hyperactive and exotic to describe it. It was comfortably placed in the rare natural phenomenon box. The major players, NASA, the European Space Agency, observatories worldwide, all turned their instruments towards it. It was a prime target, but a low hum of disquiet began beneath the surface. Of the WOW signal and 3IATLAS are aligned, transability of 0.6%. When experts put all the early data together, the radical trajectory, the weird chemical signatures, the persistent blue glow, it created a profile of something that didn't quite fit. It was a collection of small whispers that together started to sound like a single, unsettling question. In private discussions, the tone was cautious. The anomalous word was used more and more. There are still a lot of things we don't understand about it, and it didn't look like comets we are familiar with. The community was waiting for the next round of data from more powerful tools to make sense of it all. They were
waiting for a closer look. That closer look was coming, and it would not clarify the situation. It would completely upend it. The job is trying to unearth. It's all there. The universe is like sort of hiding in the darkness, and we have to bring it out. The sense of unease was a premonition. The true nature of 3-ATLAS was just beginning to reveal itself.
The James Webb discrepancy. How amazing is it that we humans have a word for something that literally flies between stars? And so far, the James Webb Space Telescope changed everything, until it pointed its golden mirrors at 3I-ATLAS. The story was about a strange but possibly natural comet. Webb was the game changer. It doesn't just take pretty pictures, it sees the universe in heat signatures and chemical fingerprints, in a kind of light our eyes can't see. It's the ultimate cosmic detective. The world's largest and most powerful space telescope has revealed unprecedented views of Jupiter. So when it focused on the interstellar visitor in the late summer of 2025, it wasn't just looking, it was conducting a deep scan. And what it found broke the story wide open. The data presented scientists with 3 undeniable puzzles, each one more baffling than the last. The first shock was the sheer size of the activity. Webb and other observatories measured a cloud of carbon dioxide gas around Atlas that was mind-bogglingly huge. The plume of gas around it is mostly carbon dioxide, 95% by mass based on the Webb telescope data. This cloud, called ʻOumuamua, stretched an estimated 348,000 kilometers across. That's nearly the distance from the Earth to the Moon. For a small nucleus, maybe a couple kilometers wide, this was like a pebble producing the fog output of an entire ocean. The scale was impossible. It was the first major crack in the simple comet theory. Where was all this gas coming from? Then came the chemistry, and it was all wrong. Webb is brilliant at this. By analyzing the infrared light, it can identify specific molecules. In a normal comet, you expect a mix with plenty of water vapor as the primary ice melts, but Webb found 3I-ATLAS's ʻOumuamua was overwhelmingly carbon dioxide, with surprisingly little water. The ratio was off the charts, unlike almost anything seen in our own solar system. And they get vaporized by sunlight before they have a chance to turn around and show up. It was made of the wrong stuff. But the strangeness went deeper. Other powerful telescopes, like the Very Large Telescope in Chile, detected another anomaly. They found significant amounts of the metal nickel in the gas, but none of the iron that almost always accompanies it in nature. This nickel without iron signature is so unusual, it's something scientists associate more with industrial processes than with natural cosmic debris. The object wasn't just from another solar system. It seemed to be built from a different recipe entirely, one that suggested processing, not just ancient freezing, with a rotation axis in the direction of the sun at large distances. That's also very unusual. The third and most crucial discovery was the heat. By reading the infrared emissions, Webb could map the temperature of the object itself, and here it found something that defied all logic. Deep inside the nucleus, far from the surface being warmed by the sun, Webb detected distinct, intense hotspots. These weren't random, they were stable and seemed to have a geometric alignment. This was the killer finding. A natural comet heats from the outside in, like an ice cube under a lamp. It does not develop organized internal pockets of heat. That requires an internal source of energy. This was the first concrete, measurable evidence that something within 3I-ATLAS was active. It was generating its own power. The object wasn't just passively melting. Something inside was awake. Quietly, the language used by the scientists began to shift. The conversation in official channels grew more careful. Internal memos and reports from the observation teams, not meant for public eyes, started using a very specific technical term: structural anomalies. It's a cold, clinical phrase. You use it to describe a crack in a wing, a flaw in a bridge's design, or a problem with a spacecraft's frame. You do not use it to describe a random piece of space. The very word structure implies something built. The central question was no longer, what is this comet doing? The whispered question in the halls of observatories and in secure chat rooms between researchers became far more direct and profound.
Has been on our radar only for about a few months. Since then, things have gotten very, very interesting.
What is operating inside this object?
Webb's deep scan had stripped away the last comforts of a natural explanation. It revealed an object that was too active for its size, made of the wrong materials and warmed by a hidden internal heart. The mystery was now undeniable, and with this new understanding, all eyes turned to its movement. If it wasn't natural ice, would it move according to natural laws? The next anomaly would be the most startling of all, because it moved from what the object was to what it was doing. And what it was doing was accelerating.